Build queue hit 500, executors idle, UI unresponsive for minutes. The culprit? A single plugin's memory leak causing heap exhaustion and full GCs. Let's break down Jenkins performance tuning, how it works, and the exact mistake behind that failure. Jenkins performance tuning is the practice of optimizing master and agent configurations to reduce build queue times, minimize GC pauses, and ensure reliable CI/CD throughput. Key areas include JVM flags, executor counts, and plugin management. JVM Heap Tuning is the single most impactful change. Set XMS and XMX to the same value to avoid resizing overhead. For heaps over 4 GB, use G1GC with a target pause time of 200 ms. Add XX, use string deduplication to reduce memory from duplicate strings. Thread pool sizing is critical. The master should have few executors, typically 816 on a 32-core machine. Agents should have executors equal to their CPU cores. Oversizing the master pool causes thread contention and GC overhead. A growing build queue indicates a bottleneck. Use the queue API to see why builds are blocked. Common causes: insufficient agents, slow SCM checkout, or too many concurrent stages. SCM polling is a major source of load. Use webhooks to trigger builds only on changes. If you must poll, use H30 or higher to avoid thundering herds. Plugins are the biggest source of memory leaks. Use a groovy script to find plugins with no dependence and remove them. We removed 80 unused plugins and saw heap usage drop 2 GB. Nginx home grows fast. Set global discard old builds to 30 days, clean workspaces, and archive only what's needed. We reduced our Nginx home from 500 GB to 50 GB. GC logging is essential. Enable it and upload logs to GCZ for analysis. Look for frequent full GCs, which indicate memory leaks or insufficient heap. Prometheus is the gold standard for monitoring. Expose metrics at Prometheus and set up Grafana dashboards. Alert on queue length 10 or executor usage 90%. For large installations, use an external database. Tune the connection pool size to 1020 and set a reasonable timeout. This improved our job scheduling by 50%. Nginx as a reverse proxy can cache static assets, reducing load on Jenkins. Configure proxy cache for static with a 7-day expiry. For agents, use SSH with connection pooling and set master executors to 0. Enable performance-optimized pipeline durability to reduce I/O by 50%. This is the same issue we highlighted at the start. Here's exactly why that happened. The Build Monitor plugin had a memory leak in its dashboard rendering thread. It caused heap exhaustion, leading to full GCs every 10 minutes with 10-second pauses, freezing the UI and causing the queue to balloon. The Build Monitor plugin had a memory leak in its dashboard rendering thread, causing heap exhaustion and full GCs. Removing the plugin eliminated the leak. The fix was straightforward. Remove the offending plugin, set proper JVM heap parameters, and reduce master executors. After these changes, GC pauses dropped to under 200 ms and the queue cleared. This was the exact incident from the hook. The Build Monitor plugin had a memory leak that caused heap exhaustion. Remove unused plugins to avoid this. Unused plugins are a liability. They consume memory and can cause leaks. Remove them. A common mistake is setting XMS lower than XMX. This causes the JVM to constantly resize the heap, leading to CPU spikes and GC pauses. Always set them equal. Setting too many master executors is a common mistake. It leads to thread contention and actually increases queue times. Keep it low. Polling every 5 minutes with thousands of jobs creates a thundering herd. Reduce to H30 or use webhooks. Without retention, Nginx home grows unbounded. Set a retention policy to avoid disk full errors. Without GC logs, you're flying blind. Enable them and analyze regularly. The article assumes JVM 17 and Jenkins 2.44+. For Jenkins versions before 2.357, the default garbage collector is parallel GC, not G1GC. Also, Roman 20 plus use string deduplication is available only from JDK 8U20 and is not recommended with parallel GC. Always verify GC flags against your exact JVM version. The article mentions thread dumps but doesn't show how to capture or analyze them. Use JStack to capture a thread dump and look for threads blocked on locks or in runnable state with high CPU. This can reveal plugin deadlocks or executor contention. Setting pipeline durability to performance optimized can cause loss of pipeline state on master crash. Use it only for non-critical pipelines or when you have external state persistence. For critical pipelines, keep max survivability or use metadata only as a compromise. To debug performance issues, start by checking the queue API. Enable GC logging and analyze with GCZ. Use JStack for thread dumps and JMap for heap dumps. Let's run through some common interview questions. How to tune JVM heap for 32 GB? Set XMS 8G XMX 8G, use G1GC, enable string deduplication. Optimal master executor count for 16 core, 816, start low and monitor. How to debug growing queue? Check queue/API/JSON, thread dumps, executor availability. And a few frequently asked questions. What heap size for medium instance? For 8 GB, set XMS equals XMX. G1GC vs parallel GC? G1GC for 4 GB, parallel GC for smaller. How to find unused plugins? Use Groovy script or plugin usage plugin. To summarize, tune your JVM heap, size thread pools correctly, optimize SCM polling, remove unused plugins, manage JNKINS home, and monitor with Prometheus. These steps will keep your Jenkins fast and reliable. Ready to go deeper? Up next, Jenkins high availability, then Jenkins pipeline best practices, then Jenkins security best practices. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.